Okay, so the notes today are going to be graphing function tables. So you guys already know how to do this. We did this in the opener today, and you guys actually did this on your note sheet from Monday. So we're going to look at this function table. The first thing that I want to identify when I look at this function table is that this time it's just y equals. So I don't have to worry about writing the function of x. I can just simply write down y equals -3 times x plus 1. What am I going to substitute for my x this first time? 2. So I'm going to put y equals -3 parentheses 2 because it's times 2 plus 1. And then I just solve. So when I go to solve, Danielle, what do I do first? Yeah, -3 times 2. -3 times 2 is going to be? What type 6? -6. And then I bring down my plus 1. Okay? Then my second step is -6 plus 1, which will be, remember, oh, sorry.
Oh, you're fine. 7.
If you owe me $6 and you pay me 1, how much you still owe me?
Oh, 5.
-5. Good. Okay? Now, because my output column or my y column doesn't say f of x or g of x or anything else, it just basically says y, I can just put my answer for y. I don't have to worry about writing anything extra. So what's my value of y equal to? -5. And then Danielle, what's my ordered pair going to be? Perfect. Okay, next one. Let's hear from Alex. Alex, what am I going to substitute for x for this next row? What am I going to substitute for x? What is this saying x is equal to? 1. So I'm going to use my equation, -3 times, what'd you say to substitute for that x? 1 plus 1. Okay, Alex, what do you do next here? PEMDAS. You see a group of numbers in parentheses. Not a group of numbers, just a single number. Do you see exponents? Do you see multiplication? So you're going to multiply. What are you going to multiply together? And, no, what's that? What's touching that? -3. So -3 times 1 is? What type of 3? -3. Guys, get your calculators out. I don't know how much more clear to be, but use that calculator. I gave you the nice fancy ones for a reason. So -3 times 1 is -3. Then I bring down my... So, the way to look at it, -3 means you don't have it. So you don't have $3. Now, you paid me back $1. How much do you owe me? So you owed me 3, you paid me 1. How much you owe me? -2. So my output, or my y, is what, Alex? And then your ordered pair. What type of 2? Yeah, it's going to be important that you put that -2. Otherwise, when you go to graph, it'll be incorrect on your function table. Okay. Moving right along. So I'm going to look at my input, my x value. What am I substituting for my x value here, Hannah? Okay, so I'm going to put y equals -3 parentheses 0 plus 1. Okay? Where do I start to solve here? So where did I start each of these other equations? What did I start by doing? Did I do parentheses, exponents, multiply, divide, add, or subtract? I don't see any parentheses. When I say parentheses, I mean a group of numbers in parentheses. Are there a group of numbers in here? Nah. So, no P. So I go to E, exponents. Do I see any exponents? Do I see any M, multiplication? Yeah. Anytime a number touches parentheses, it means to multiply. Okay? So what's -3 times 0? Times 0 is? Anything times 0 is? 0. So I'm going to bring that 0. And then what do I bring down after I multiply these two together? What's left that I haven't done yet? Okay, the plus 1. Hannah, what's 0 plus 1? What's 0 plus 1? Like, I don't know, leave me alone. Okay, so we're saying y equals 1. So what do I put in my output column for y? And then your ordered pair. So remember, ordered pair is made up of x and y. What was my x value? And what's my y value? There you go. Nice. Kaylon, give me that worksheet.
No,
Yes,
no,
sir.
Yes,
Yes, sir. Yes, sir. Yes, sir. Jeremiah. I'm just gonna set that right next to you. If he tries to reach for it, elbow him. Don't really, but.
Yeah,
Okay, Kaylon. What am I gonna substitute for x here?
1, -1.
Ooh, a good correction. So -3. Can I put -1 like this?
Parentheses.
Put parentheses to show multiplication. Good. +1. Okay, go ahead and solve.
It's going to be +3. You're going to put +1. It's going to equal 4. You're going to write 4 in the y's. Then you're going to put parentheses. Your x is -1. Then you're going to put, then your y is 4.
Good.
Then you got to put it on the bar graph behind.
Good. So with these ordered pairs now that you have, you're going to go to your coordinate plane right below it, and you're going to go ahead and plot those points. Once you plot those points, you can go ahead and draw that line like what we did on our opener today. Okay?
No, you can't draw your line on these points because they're crooked.
They shouldn't be crooked.
Yeah. They all on straight.
If you did not get them, Hannah, did you get all yours down? Danielle, did you get all yours down? Okay, look off of Danielle's. Slide up to the next Danielle. Hannah, look at Danielle's. Alex, you're tall. Lean over, look at Danielle's, and get it down. Okay, so let's look at this. So the points that I'm going to plot, my first ordered pair that I got was 2, -5. So I start at my origin. Well, first I'm going to label these. X, Y. So I'm going to start at my origin. I'm going to go to the right 2 and down 5, right? So 1, 2, 1, 2, 3, 4, 5. I'm going to plot my first point there. My next ordered pair is 1, -2, correct? Is that right? So I'm going to start at my origin. I go right 1, down 2. Okay?
See?
My next ordered pair is 0, 1. Is that right? So I start at my origin 0. I stay put because my x is 0. This is where you messed up. Right here. So this next ordered pair is 0, 1. 0, you stay put for your x. Your y is 1, so you go up 1. You did it opposite. There you go. See, that's how we then know if our table does not make a straight line, we've messed up. Then our last ordered pair is -1, 4. So I start at the origin, go left 1, up 4. Then draw your line.
You gotta look.
That's fun.
Isn't it?
Yeah.
They love math, especially first thing in the morning. Did you all draw your line? Oh, but I see some lines that aren't any good. Ooh. Now, this right here, that's perfection. That's what I want to see. So when I say almost, oh man, almost perfection.
Ow!
But for the most part, this is what I see. The first thing I noticed, he used a straight edge, whether it was his ruler, his binder, or his ID. Now, beyond that though, he took his line and he drew it from one, ooh, that's going to be a bad line. He drew it from one end of his coordinate plane all the way through the other end of the coordinate plane. So if you notice here, my line goes all the way to where those lines end, top and bottom. So when I say through the coordinate plane, I mean I didn't stop short here. I went all the way to the end of the plane, okay? So my line's straight. It goes through all of my plotted points. It goes to the end of the coordinate plane, and then it has an arrow on the end of each one, each side of the line, to show that it's going to go on and on and on. To me, that is a perfect point. So what I would like to see more is that, see how your line and your arrows almost end on those points? I want it to go out just a little bit further, and then your arrow, okay? I know it's extra and I know it's picky, but get used to it. Yeah.
How about when they missed the last line,
No.
and then they hand draw it from the, yeah.
Yeah.
Is that what they do?
Okay. So,
That's what I just did. Hold on. Chill, came back. You started on me.
so when graphing a line, make sure, oops, when graphing a line, we're gonna make sure, yep, we're gonna write it. So when graphing a line, make sure
Denigan A.
You started first.
the line,
My last report card, I was getting all A and B. Good. I'm an A and B student. Go.
the line goes through each plotted point. Oh, I could have said point. Each point's fine too. Sometimes I'm a little long-winded.
I said each plotted point.
So the line goes through each plotted point. I'm going to put in parentheses, use a straight edge. You do not have to, but if you don't remember to, I'm going to use my big old red pen to take points off.
No.
She said she got a big old
So
red pizza.
the line goes through each plotted point. Actually, that could be step 2, use a straight edge to plot your line. What's the other third criteria that I want for when you draw your lines? The line goes through each plotted point. Step 2, you're using a straight edge. Step 3, not necessarily step 3, but criteria 3. It doesn't matter what order you do them in. How long should that line be? Super long, long enough to go through each coordinate plane.
Yeah, I was trying to think of it.
Man, you can't be jumping like that. You just drew an arrow and went on to step 3.
I did. So the arrow means straight edge, like use a straight edge. And then the last criteria, what should be at the end of each of your lines?
Arrow.
Well, it's still January.
Arrow.
Yes.
Hey guys, don't break my rulers. Okay, once you have that done, once you have that down, do you have a backside?
Yeah.
Flip it to the backside. We're gonna do one more.
No,
Actually,
nah.
I don't know, because you guys keep running your mouth. Be quiet. Quit talking. Quit interrupting me. We're going to take a vote. Raise your hand if you want to do this last example. Raise your hand if you prefer not to do this last example because you feel like you understand what you're doing. Raise your hand if you still feel like you know what you're doing. Once you see what kind of equation you have.
Oh.
Oh, no. You
So,
should have said the full thing.
all right. So we're going to do. We're going to do this super fast. When we do this super fast, because we're going to go ahead and do this example, I am going to allow you to take one whole problem off of your worksheet I'm going to give you. Okay? So I'll meet you halfway here. If you hang with me for, are you leaving me now?
It's 9:10.
Can you do two? Can you do? Give me 2 more minutes, and then I'll get you a piece of candy, and then you can head. Okay, just 2 more minutes. I want you to get at least this first part down, Michael.
Almost got low blood sugar.
So y equals 1/2 times x minus 3. What am I going to substitute for x here? Good. So it's going to be 1/2 times 4 minus 3. See you, Jeremiah. So, on our opener the last couple of days, with the exception of today, we worked with fractions times whole numbers. So you can either, A, type it into your calculator, 1/2 times 4, and it will give you the answer, or B, just work it out how I do. So when I work it out, I take the numerator times the whole number. So what's 1 times 4? And I divide it by the denominator. What's 4 divided by 2? Say it again. 2. That's the answer. So 1/2 times 4 is 2. So once I multiply that together, I bring down the minus 3. So what's 2 minus 3 going to be? Negative 1. So what's my y value? Negative 1. What's my ordered pair? 4 and negative 1.
Keep writing.
We're going to do one more. We're going to stop after this part of the function table, okay? Just for time's sake and attention spans. So, what's the input going to be for my next value of x? So I'm going to put y equals 1/2 times 2. What's the rest of my equation? Minus 3.
It's gonna be 1.
Okay, so let's take a look at it. So I'm going to take my numerator times my whole number. 1 times 2 is 2. 2 divided by 2 is 1. So 1/2 times 2 is 1. Or if you just use your calculator, you got 1. What do I bring down with that 1? Negative 3. What's 1 minus 3? Negative 2. So what's my output or my y? Negative 2 and my ordered pair. What's my ordered pair? 2, negative 2. And that's where we'll stop.